My name is Kalesha Bullard, and I'll be discussing work on exploring human-driven feature selection for robot task learning, done with my advisors Sonia, Chernova, and Andrea, Thomaz. The feature selection problem is very important in enabling a robot to accurately represent a task. In typical learning from demonstration settings, a robot's only given a small number of training examples from its human partners, and the challenge is that this may be insufficient evidence for computational feature selection techniques, which rely on identifying statistical patterns in data. We want the robot to autonomously construct this task representation using the limited training data it's expected to have access to, and we can leverage the human user for acquiring this feature information. We have two research questions we're exploring. Is a domain expert able to identify a subset of informative task features as accurately as computational feature selection? And does the way in which the information is elicited from the user impact the resulting quality of the feature selection? The robot's goal here is to learn from the human teacher how to distinguish between each type of object needed for the task. We experiment with an unpacked groceries task with 4 object classes. We examine 3 families of experimental approaches compared against baselines of no feature selection and computational feature selection. For direct approaches, features are directly enumerated by a human by selecting them or pruning them from a list. Training instances are generated randomly. For indirect approaches, the teacher communicates about features by selecting a small subset of representative training instances, and then computational feature selection is used to infer what features the human was attempting to communicate with the instances selected. For combined approaches, people first provide a small set of training instances and then explicitly enumerate which features they were attempting to communicate. We test 2 experimental conditions. On the top left, since learning from demonstration domains typically have limited training data, it's important to characterize which feature selection approaches enable the robot to discriminate aptly with only a small amount of data. On the top right, we're also interested in characterizing how the different approaches improve in learning performance as the amount of data increases. What we observe on the left is that allowing a human to directly select task features, as shown by the red bars, yields a statistically significant increase in expected learning performance as compared to using computational feature selection, shown by the green bar. What we observe on the right is that with a large amount of training data, the best human-driven feature selection approaches and the computational feature selection approach perform comparably, and all are statistically significantly better than the learner with no feature selection. Our key insights are that a robot learner can in fact leverage the knowledge of a domain expert to identify informative task features. Humans are especially valuable in learning from demonstration domains where training data provided is typically limited, and direct enumeration of features is the most effective strategy for eliciting feature information. Please come by my poster for more information. Thank you.